All right, functions, welcome back to class. I hope you had a good weekend. All right, we are starting our new unit. It is Unit 2 functions. So in your notes, go ahead and label as that. So we're going to go through, this is Intro to Functions. Our warm-up for today is right here, so go ahead and hit pause, and I'd like you to go through this. Okay, so order of operations tells me that I need to square this before I can multiply this, because exponents come before multiplication. So I get 2 squared, which is 4. So negative 5 times 4 minus 4. And then it says multiply before we add and subtract. So I get negative 20 minus 4, which gives me negative 24. Okay, so I'm going to do this one. So I need to do grouping things. And inside the groupings, I have this squared. So really what this says is negative 1 times 2 squared plus 1. That's what that one really says. So I get 2 squared, which is 4, times negative 1. So then I get negative 1 cubed plus negative 4 plus 1. And then I have to do this, so I get negative 1 cubed plus negative 4 plus 1, which is negative 3. And now I can do this, so negative 1 cubed is negative 1 times negative 1 times negative 1, which is negative 1 minus 3, which is equal to negative 4. Okay, and this one is just left to right. So I am going to do negative 2 times 4, which is negative 8 times minus 1 minus 6. Negative 8 times negative 1 is a positive 8 minus 6, and I get the answer is 2. If you have any questions, please let me know. If you got something different than me, let me know that too. All right, so now here's our first objective. You don't need to write this. We're going to distinguish between an independent and a dependent variable. So we often describe one quantity in terms of another. So the amount of your paycheck, if you're paid hourly, depends on the number of hours you worked. So this is something that we see in the real world. How about the cost of the gas at the gas station depends on the number of gallons you're going to use in your car. So that kind of thing happens. So we have something's going to change another thing. Something's depends on another thing. The distance traveled by a moving car at a constant speed depends on the amount of time that you're doing it. So that would be like if you're gonna, so distance that you traveled at a constant speed, so if you never slow down, will depend on the time that you do it. And so the value of the variable y will always depend on the value of the variable x. So then y is always your dependent variable, and x is your independent variable. So go ahead and hit pause right now, and you can get that in your notes. I would mostly write this in my notes if I were you, because this is something that's going to come up. And actually, my son and I were talking about the hours that he works and the amount he gets paid. And I was like, we're talking about independent and dependent variables. So this is something that actually occurs in real life. So go ahead and hit pause. All right, so functions. Why are they functions? They are functions because for every x value that we put in and we do some stuff to it, we get an answer and only one answer for it. So an example of that would be if I put in, my input is 2, my rule is x squared. So if I say 2 squared, I'm only going to get 4, no matter what. But an example of a non-one would be plus or minus x plus 3. So, oops, sorry, I put the plus or minus in the wrong spot. X plus or minus 3. So if I put in 2, I get 2 plus 3, which is 5. So that's one answer. But then I also get 2 minus 3, which is negative 1. So I get 2 different answers. So this is not a function. Another thing is domain. We're going to talk more about domain, but domain are all your x values, and range are going to be all your y values. Something that you may have seen in the past is this f of x. F of x and y mean the same thing. So you may see y equals, or you may see f of x equals. They are the same thing. But when we're talking about functions, we usually name them. So we're going to go into that in a minute. So if you want to get this in your notes, you can. I'm going to go into all of this stuff in more detail. So we've got our independent variable x. We've got our dependent variable y. So a relation is a set of ordered pairs. So a relation is a set of ordered pairs. I'm going to go next. If you want to hit pause, now would be a good time. A function, the definition of a function is a relation in which for every value of the first component of an ordered pair, there is exactly one value of the second component, meaning there is only one x and one x has only one y that goes with it. So if my points are 2, 3, and then I have another one that says 3, 2, that's fine. So the x's can't be repeated, but the y's can. So that is a function. So if we're looking at these ones, these are called sets. This is a set of points. And what we're looking for is, does it define a function? So are any of the x values, are they repeated? No. The same x value pair with a different y value. So if I said, what does -1 equal? You would have to say 2 or 3. So in a function, no two ordered pairs can have the same first component, meaning x value, and a different y value. Does that make sense? Let's try this one. So we've got 5, 4, 6, 4, and 7, 4. So we've got all of our y's are being repeated. So is this a function? Yeah, we have each x value is paired with a y value. This does not violate the definition of a function. If we were to look at this graph, it would just be a line, right? So it would look like this. And then we would have at 5, 4 would be right here. And then 6, 4. And then 7, 4. So it'd just be like that. It's not a line, but it would look like a horizontal line if we drew a line through it. Oh no, the picture on this got messed up. Let me fix this really quick. See if I can find my mouse. Okay, so these relations and functions can also be expressed as correspondence and mapping from one set to another. So if we have, where did my pen go? Let's see. So if I say 1 is 2 and 2 to 5 and 3 to 6, this is going to be a function because for this, I have one of these. I can only have one side, this side can only go to one of those numbers. So the same is true here. So this is going to go from 1 to 2, 2 goes to 2, but 2 also goes to 6, not a function. So since this one doesn't even have enough numbers to go to it, it would go like this. So 2 to 2, since these go to two different ones, it can't be a function. So just like the x's can't be repeated, this is the same way true. So this is basically saying 2 belongs to this one and this one. So we're going to talk about domain and range. So in a relation, the set of all values of the independent variable x is the domain. So on this one, all of this would be the domain. All of this would be the domain. This would be the range. This would be the range. So that's how it looks in mapping. And then the set of all values of the dependent variable is the range. So domain relates to left and right. So if you're looking at it, how far to the left does it go? How far to the right does it go? Range, how low does it go? And how high does it go? So it's top and bottom. So domain, range, domain, range. I look like I'm voguing, but I'm not. I'm doing domain and range, okay? So go ahead and hit pause and get this in your notes. All right, so go ahead and get this in your notes. Hit pause, put this in your notes. Okay, we're going to give the domain and range of the relation that represents by the table of cell phone subscribers. And does it define a function? So the domain is going to be all of the years. So the subscribers depends on what year it is, right? So 1999, the year 2000, 2001, 02, 03, and 04. And then the range are going to be all of the subscribers. So does this define a function? Yes, it is a function because we don't have any x's being repeated. And so then it is a function. All right, we're going to give the domain and range of this relation. So this is essentially this is a negative absolute value function. So what we're looking at is how far negative is it going to go? Well, it's going down forever because of that arrow right here. Since we have this arrow, it's negative forever, so we're going to have negative infinity. But it's also going to the right forever, so it's going to go this way forever. So this way forever and this way forever. So we're going to have, whoa. Hold on, someone's at my door. All right, sorry. So domain is going to go negative infinity. It's going to go all the way over here, and it's going to go all the way to positive infinity. So let's see if I can get this to go next. Let's see. So the arrowheads indicate that it's going infinitely left and right, which is what we just talked about. So the domain is going to be negative infinity to infinity. So then the range is top and bottom. So it is starting at 4. It doesn't go any higher than 4 on the y-axis, but it's going down forever. So we're going to say that the range is negative infinity all the way to 4. So when we're doing domain and range, you always put the smallest number first, then the largest number. Smallest meaning the more negative is smaller than a positive number. So make sure you do that. So it's always going to be the smallest number to the largest number. All right. So unless we say otherwise, we're going to assume that all of our functions are in the real numbers universe. So all of our stuff is going to be in real numbers, meaning we won't have any imaginary numbers right now. We won't have the square root of -1 at all. So no imaginary numbers, no complex numbers. We're staying in the real numbers 1. So we're going to identify functions defined by graphs and equations. So vertical line test, you do need to write this down because I'm going to be asking you questions. Is this a function? Yes, it passes the VLT, the vertical line test. If every vertical line intersects the graph of a relation and has no more than one point, then the relation is a function. Meaning, if I'm looking at these graphs and I draw, let's see if I can get my pen to work. If I draw vertical lines through here and I only cross one point and never again, then it is a function. Now, if I look at this one, whoop, if I drew a line, whoop, oh, and I hit it again. This one, if I draw a line, pretend that's straight. That only hits one time no matter what. So you have to look at the whole function. So it only hits once there, hits twice there. Function, not a function, okay? So we're going to use the vertical line test to see whether this relation is a function. And it is because it passes the vertical line test. And we want to put that. VLT. Okay, so what I would like you to do is you're going to have to hit pause a bunch of times. I would like you to put all of these graphs in your notes. These are called parent graphs. So we have the constant graph right here. We have, and that is f of x equals c, meaning it just equals a number. We've got f of x equals x, which is just a line, it's just a linear. The absolute value, quadratic, square root, cube root. This is a rational one. We're going to go into those in a little bit. The rational will be lower units. There's another rational one. There's logarithm, exponential, and then a step function. So I'm going to set it for a second, and I can hit pause, and then I'm going to get these into your notes. And I'm going to get this last row in your notes. So that is what you should be working on. I do have a worksheet for you to do some practice to see if things are functions. And I will see all of you tomorrow. Have a great day.